So in continuation to the previous videos, further we'll be extending with respect to the inversions of mechanism. So when we do inversion of a mechanism, we will see that one of the kinematic chain it is fixed. So in the mechanism is one in which one of the links of a kinematic chain is fixed. So different mechanism can be obtained by fixing different links on the same kinematic chain. So this is known as inversion of a mechanism. So by doing inversion of the mechanism, we can get the other work done. So this helps in if we do inversions of any mechanism, that will help in getting the work done in one or the other way. So inversions of a 4-bar chain, if you take, so the examples of inversion of 4-bar is beam engine, coupling rod of a car locomotive, Watt's indicator mechanism. So like these three examples we are supposed to discuss in detail. So inversion of a 4-bar chain, if you take beam engine, in the beam engine here the diagram is given. So line diagram as well as the 2D diagram it has been shown here. So in the you can see a lever it is there which is link, which is connected with respect to point C and point E. So the crank rotates with respect to the length AB. So frame is the link 1, crank is the AB which is named as link 2. When it rotates, link 3 it is going to make motion. Simultaneously the lever also it is going to make to and from motion. So it will be having an impact of the piston and the cylinder. So like this, the crankcase which rotates it gets transmitted to the piston and cylinder alignment. So this mechanism it is used to convert rotary motion into reciprocating motion. So if you do inversion of 4-bar mechanism, that is nothing but coupling rod of a locomotive. If you take a locomotive where wheels will be present in the outer frame and links are connected to the inner frame. So here A, B, C, D is the links where you are going to have. So AB is the link which is fixed, that is named as link 1, and the link 2 and 3 which are parallel to each other. BC and CD is parallel to each other, and link 3 and link AB it is parallel to each other. So links AB, AD and BC just having equivalent act as a crank are connected to the respective wheels. Means if you give input to the one wheel, it is going to advance the second wheel. The link CD acts as a coupling rod, and the link AB it is fixed. So here to maintain a constant center distance between them, so like this it has been coupling has been done. So this is meant for transmitter in rotary motion from one wheel to other. Suppose if the wheel one wheel it is moving, other wheel you need not give the energy to move. So it will be able to move very easily, and the power what all it is generated with respect to the joint A, it will be transmitted to the joint B, where link AB it is fixed. So further going with the inversion of 4-bar mechanism, the example is Watt's indicator diagram. It's a double lever mechanism at vessel. So here you can see the number of links are more here, but you see from the rest position to the displaced position, it has been shown the new position. So uh, here the new position it is named as B dash C dash D dash. So existing structure what it is shown is A B C D EF is the EF is the points where it is shown. So here what all we take A B C D is the initial position where for link 1 that is at the point A it is fixed. So at the link E here the motion it is going to happen. Rotary motion is given to the link E. So here when the cylinder piston reciprocates, here you can see it goes to the new position that is B dash C dash C dash. So if you give a small displacement here, you can see it goes to the new position and it is going to come back to the rest. So like this, the crank which is going to rotate at point E, it keeps on it keeps on displaced to the new position. Like this Watt's indicator mechanism works. So the existing position and the new position, it is the existing position it is shown in the blue line, and the new displaced position it is shown with respect to B dash, C dash, D dash, and E dash. So it is shown in the pink line. So like this, the Watt's indicator mechanism works. So further, if you take the slider crank chain mechanism, how it works. So already we have discussed about the slider crank chain mechanism so many times. So once again here you can see the there are frame is the link one, crank is the link two, connecting rod is the link three. So here the so here you can see the piston rod and the cylinder portion is there. So here the links are 1, 2, 2, 3, 3, 4 are the turning pairs. Link 4 and 1 are the sliding pair. So at the given slot it is going to slide. So this is the slider crank mechanism. So here it shows the inversions of a single slider crank chain. Here you can see while the crank is fixed means AB is fixed. In the second diagram here it shows the connecting rod is fixed, and in the third position you can see the slider is fixed. So you can check when we constrain the link with respect to different positions, you'll be able to know what mechanism or what motions will be able to achieve. So this inversions of single slider chain shows that where exactly it is going to move. So inversions of a single slider crank chain, if you take bull engine, bull engine is an example. Oscillating cylinder, uh, norm engine is an example. Crank and slotted lever, quick return motion mechanism. Whitworth quick return motion mechanisms are the example. So bull engine, if you take, it's a bull engine or a pendulum pump. Here if you consider, here it is shown the 3D model. So here is shown is in the 2D diagram with the help of sketch. So this inversion is obtained by fixing the cylinder on both the sides. That is on the link 4. Both the cylinders are fixed. So now when the crank or link 2 rocks the connecting cylinder, this oscillates about a pin pivoted to the fixed link 4 at A. So the piston attached to the piston rod reciprocates. It supplies water to the boiler, and it keeps on making the piston rod to reciprocate inside the cylinder. So further, if you take the cylinder and the connecting rod, which has got a piston rod, so it is used to convert reciprocatory motion into rotary motion. So here you can see connecting rod, it is fixed. So here link 3, the connecting rod forming the turning pair, it is fixed, and you see crank rotates and the piston rod which is going to reciprocate inside the cylinder. So here the connecting rod, it is fixed, and the piston rod which is movable inside the closed cylinder. So in the radial IC engine here you can see whether it's a triangle or quadrilateral, and how it is going to help in transmitting the motion. So here the geometrically the three sides of the triangle it is defined, taking with different dimensions. So it is connected with the required link as per the need, and even the quadrilateral also you can see dimensions are not equal for all the four links. 95, 70, 75 and 30 it is taken, and in the triangle it is 75, 65 and 80 it is taken. So you can use the dimensions and you can modify the link based on the required motion where you need it, you will be able to achieve. So in a GNOME engine you can see the point in the cylinder it is fixed. So there are piston and connecting rods filled in the six different positions. So the crank is fixed at point T. The cylinder reciprocates. The cylinder reciprocates, and you can see in each case the cylinder is going to get admitted to the new position. So engine rotates in the same plane. So engine rotates in the same plane. Like this, the GNOME engine works.